So today we're going to be looking at a guide to security in PHP. I'm a Arriva, as you know, and we'll be looking at this topic today. So we'll be looking at the why, the history, how security works in PHP, what tools we can use on security in Year 2, my personal favorite, and then we'll look at some questions. First of all, PHP was a widely used programming languages both in the mid 90s and early 2000s. The older the programming language gets, we notice that the easier it is to hack it. Why is that the case? That's because more persons will be able to learn um, the nooks and crannies, all the possible problems associated with a particular language over time. Now, PHP applications were vulnerable to a variety of attacks, and because of the simplicity of PHP, these attacks became a serious vulnerability for the language. So the response was that there was a secure configuration guide released in 2003, and they also had the PHP security project, which commenced in 2006. Then version 5 improved the security, had support for SQL injection prevention, because SQL injection was one of the biggest issues because PHP was more of a server-side language and was actually used for database management. So that was one issue. 2011 PHP version 5 also helped for password hashing and session management, so that you could turn off the section and not allow someone take over using a stale session. Then the community also focused on it. PHP 7 in 2015, it had more security features on it and encryption algorithms and stuff. All of these things are actually embedded in all the frameworks that PHP frameworks we have. Then we are going to look at best practices for securing PHP application and how to use security tools and how to use frameworks appropriately. First thing, looking at the best practices, we have input validation, output encoding, SQL injection, cross-site request forgery, and file uploads. Yeah, that's one issue, file uploads. People uploading malicious files in order to attack a software. So that's one thing. We should look at these 5 best ways we should be able to prevent things from happening to your website, especially from the back end. Okay. The other ones you could also look at it is error handling. So session management, that's one thing. Then use of latest version and security patches and security libraries, like that a set of libraries that can be used to protect your software. All you need to do is add those parts into your program. Then we should also be able to review the code for potential security vulnerabilities and probably use an ethical hacker to try to check how to penetrate. Then one of the tools, there are several tools which we can use. We have the OWASP PHP security project, which I think it usually comes with your PHP PHP installation. Then you can, some of the others you can just turn it on and just add it. You can just turn the thing on. Sometimes they're mostly off, so you can just simply turn them on to use them. Then there's PHP CSRF, PHP encryption, PHP crypt. I've not used most of this, so can't really say too much about it, but over time get used to this. Then we have Symfony security components. Then there's Laravel security systems and PHP login system. This PHP login system, if you look at it up on Yi, which I'm familiar with, yeah, it has several protocols which try to prevent this. For instance, the encryption of the login system and the protection of it from the backend. Then, but they are not substitute. That's one thing. You just simply call the security options and or add it to your code, but it's not really substitute for proper coding practice, and it cannot really always guarantee complete security. That's because people have already known these software, these systems, and try to go over it and try to break it. So adding just one isn't just the case. If you have improper code, they can see that okay, this is somebody that doesn't know what he's doing, and then it'll be easy for them to go past your system. Word of caution is that not a magic ring of invisibility, and that's one thing. If you don't do it properly or you don't install them properly, it will not guarantee the security of your site. So it's up to you to properly address and fix any vulnerabilities. It's not the job of just the security listening. That's just an it's more like a shield. If you don't know how to use the shield very well, you still get shot. So it's not all types of attacks. So there's protects from certain type of attacks. Okay, so you have to know what type of attack. You have to like think what kind of attack will most likely come to this site. What am I protecting? So know what you're protecting and know how to block it. Sometimes having too many is not really having many. It's not really the best of security. It's just what are you protecting when you do that. Then let's go through the security in key for securing web applications. So the first one is input validation. When you validate their inputs, it helps to protect whatever the software, your software, and even your it just protects everything at the back end. It protects what you're trying to keep secure. For instance, if somebody, if you remember, WhatsApp has this problem with the GIF, where they use the GIF because it does not have an encryption for GIF. So people were using GIFs. Once you open it, they take over your account, and that was a problem from WhatsApp itself because they did not validated GIFs because of the complexity of the GIF GIF graphic. So validation in YE protects from those kind of issues. So the next one is output encoding. That's what they call cross-site scripting attack. I don't really understand it that much, but if somebody can go deep to check out what that is, cross-site scripting attack. And I think that's one of the most common attacks that most script kiddies use. Then there's also an SQ injection protection from YE. YE does that for you. It also handles errors and just give you a friendly message, so you see that it just hides sensitive information from the problem. Because if instead of it showing, if it shows the problem of the site, like let's say the error, full error, somebody will be able to see what's up and use that as that's like a vulnerability. So once it just simply just shows error, doesn't really explain. Then there's this cross-site request forgery attack, okay, which they use a cookie to do so. So it generates and validates that anti-tokens, those tokens that it gives to every site. I think I've used that before on YE. There's a token, particular secure token that is to keep you always have to have the access token. In fact, you have to add it to your database. So that it will keep refreshing those tokens for user access. Then it has this access control system where it restricts access to certain parts of the applications based on the permissions that have been given. So then there's built-in management system manage each of your sessions. It also encrypts data. It encrypts everything, including your password. Encrypts everything and decrypts it when you need it. So you should watch out for the pitfalls on this thing. You have to configure the access control system correctly and validate user inputs. If not, you still have injection attack. You have to use extensions that provides additional security, such as the password hashing, password sorting, and even password encryption. If you have to use them correctly, don't just copy codes. Everybody's just go online and copy codes verbatim. Try to tweak it to make it look different, so that you can because most persons imagine that the sites are the same. Most persons just say, okay, type online how to do this. Most of the first things that pop up is what most persons are actually using on their website. So you have to just make sure you look different, like plagiarism, like you just refresh it and everything. Then it provides built-in protection against SQL injection attack. We talked about that and this thing. But the problem is that your application has still been vulnerable to SQL injection. So you have to do it in such a way that when the user does not have access to your database, so you can protect it actually from the database itself. I've tried that before. Yeah, to protect from the database, you don't allow that the database should not be able to drop your this thing. They should not be able to confirm this thing. They should only be able to take something out or drop something in, but cannot touch your tables or anything. Okay, and if the developers do not implement that CSRF well, tokens well, it will still be vulnerable. Then there's the file inclusion vulnerabilities, several other vulnerabilities here. File upload vulnerabilities, authentication authorization, insecure session management, and insecure encryption. But I want to look at this insecure session management. That if you don't configure the session settings very well, like know the timing, right? For instance, you have to set the timer so to know how for this, and you should be able to think how long would my this thing spend on this, and how long before it needs to, maybe the token needs to be sent again or something like that. But one thing is that when you look at when it, how do you want it? Do you want it that when the person closes it and returns back, it automatically clears up the session, or you want it that the session keeps being open? It all depends on what you are protecting. If you are protecting, let's say it's a banking app, you definitely want to close the session. So if you need the slide, we can actually go through questions like this. Okay, so hit me up. Thank you. Have a lovely day.